We continue Unit 16 with growth and decay word problems. We will be talking about compound interest. Compound interest is in the formula A equals P times 1 plus R divided by N, all raised to the N times T power. A is equal to the balance after T years. P is the original investment. R is the rate in decimal form. N is the number of times per year compounded, and T is the number of years. This formula can also be used to calculate values that decrease. Just change the plus to a negative, so that we have A equals P times 1 minus R divided by N raised to the N times T power. Let's look at an example. The amount of $500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? First, I need to decide what formula I am using. I am looking to see what my future value will be, and it will be hopefully increasing. I will be using the top formula, so write that down. Make sure that's raised to the N times T power, not multiplying, so I'll put a little caret key to remind us. Now I need to find all the players in my problem. A for balance after T years, P the original investment, the rate, the number of times per year compounded, and T the number of years. Since I'm looking for the balance after 3 years, then I'm looking for my future amount, so I don't know A. P stands for principal. The original investment, that means the beginning amount, the amount I deposited. So that I do know is 500. The rate is 9.5%. We never write it as a percent, so take off the percent sign and move the decimal back 2 spaces to the left, 0.095. N is the number of times per year compounded. We are compounding monthly. That means 12 times per year. T is the balance in the account after how many years? In this case, 3. Now we just plug these values back into the original equation for each of these letters. I do not know A. P is 500. The rate is 0.095. The number compounded, N, is 12, times the number of years, which is 3. Turn on your calculator, clear it out, and this is what we will put into the calculator. One quick change. Since we are using the calculator to find this, need to make sure that you have parentheses surrounding the rate divided by the number of times per year compounded. So you will actually have a double parentheses here on the end. If you do not do this, you will end up with an incorrect answer. So we have 500 times 1 plus, this is where the parentheses come in. All fractions are wrapped in parentheses when you use a calculator. Divided by 12. Now I have this parentheses closed off, but I still need to close this one off. So this is the double parentheses. Raised to, and then 12 times 3 is 36. We get $664.14. Need to make sure we include the dollar symbol because we are looking for a dollar amount. Example 2. We have a collection of baseball cards that cost $150 in 1988. In 1994, the value of the collection increased by approximately 7.5% each year. What is the value of the cards in 1994? So again, I need to get all these pieces to my puzzle. I'm wanting to see how much it increased, so this one practically tells us which formula we will be using. So write this formula down. Raise it to the n times t power. Now we need to figure out all the pieces to our game. I want to know the future value of the cards in 1994, so I don't know A. P is the amount that I started with. How much did it cost me to buy those cards? Well, it cost $150. The rate is 7.5%. Remember, we have to change that to 0.075. The number of times per year this is compounded, it says each year, so that's only one time per year. And time, we have to find, because it doesn't say exactly the time, but we do know that we started in 1988 and end in 1994, so there's 6 years there between those. So there is my problem. Remember, we do have to get this calculator ready, so we want to put a parenthesis around our fraction. And then 1 times 6 is just 6. So I'm going to go ahead and just put that there. And now let's look at our calculator. Clear. We have 150, open parentheses, 1 plus 0.075. Oops, I did not put this in parentheses. Open parentheses, 0.075 divided by 1. Close off the second parentheses and raise this to the 6th power. We get A is equal to $231.50. Example 3. How much would you deposit in an account that pays 6.5% interest, compounded semi-annually, to have a balance of $5,000 in 15 years? So I will be using the addition formula. So write this down. I need to find all the players or pieces to my game. In this problem, I'm not given my deposit, and that's my initial amount, so I do not know P. I do know how much I should have in 15 years, which is $5,000. It pays 6.5% interest, so I need to change this to a rate of 0.065, or number of times compounded per year. It says semi-annually, and that means 2. And it gives me 15 years. Now the last thing I need to do is to make sure I have my fraction wrapped in parentheses. And 2 times 15 is 30. So now I have this calculator ready, but this time I have a twist. I don't know P, so I need to figure out all of this. Okay, so on this side I have 1 plus in parentheses, open parentheses, 0.065 divided by 2, close parentheses, close off the first set of parentheses, raised to the 30th power, and we get 2.61. Now this is Algebra 1, and I want to solve for P, the principal. So we divide both sides by 2.61. So P is equal to $1,915.70 or 71 cents. Example 4. The value of a new car was $12,500. It decreases 20% per year. How much does this car cost after 3 years? So we are using a decreasing value. So my formula has the minus sign in it. 1 minus the rate divided by n, all raised to the n times t power. In this case, I need the future value, which is A. We don't know. P, it costs me $12,500. The rate, if we take off the decimal, move 2 spaces over to the left, is 0.20. The number of times compounded is per year, so that's 1. And the time is 3 years. So in our handy dandy calculators, let's input this information. Again, to be calculator ready, I have to have a double set of parentheses here. 0.2 divided by 1 in parentheses, close parentheses, raised to the 1 times 3 is 3. And our car, 3 years later, is only worth $6,400. That's sad. This concludes the last flap of your foldable.